Yeah, so this is the chemical laboratory. So here we have various equipment. This one is called UV-Vis spectrophotometer that is used to analyze basically anions, or in other words, radicals. So we have sulfates, we have nitrates, we have phosphates, and others. So that can be done on water, soil, and any other material, because that will eventually be changed into the right matrix in order for you to make use of it for the analysis. You will require some standards and specific reagents to aid in color development if it will be required. For example, nitrate, you need specific reagents, sulfates, phosphates, etc. Now, similarly, this one is also a spectrophotometer, but then it is able to do both metals and non-metals. And of course, it's very robust, where you simply need a 10 ml sample in terms of quantity. And then we have already prepared chemical reagents which come in sachets. And these are now used to simply prepare the sample and eventually do the analysis using this. Now, you can also be interested in this. This is used to heat a sample, specifically wastewater, okay, in the process of COD analysis. COD is chemical oxygen demand, which is usually analyzed in wastewater. So wastewater, of course, you can have raw wastewater and treated wastewater. So the COD is a requirement for such wastewater, because when you are now disposing into the public sewer or into the environment, NEMA requires you to quantify the levels of chemical oxygen demand as one of the parameters. Now, we have this equipment. This equipment is called Fourier infrared transform spectroscopy, and it's usually used to determine what we are calling for example, when you look at carbon compounds, we have the functional groups. Yeah, that's the one I was looking for. It is usually used to determine the typical functional groups which are present in a particular sample. For example, hydrocarbons, we talk of the carbon-carbon double bond, the carbon-carbon triple bond, the carbon-carbon, and so on and so forth. So basically, the functional groups present in a particular sample is used, is determined using this equipment. Okay, here we have a GC, a gas chromatograph, that uses the technique of gas chromatography, and this one is used to determine the compounds, of course, organic compounds for that matter, and in most cases we are using it if you have a product, a finished product, or even raw materials that need quantification in terms of the present organic compounds, then you simply come and use this equipment. It has got its own procedure where the sample, of course, has to be changed into the right matrix. The matrix is usually water, and it is subjected into the chamber using a needle, and the putty is usually, yes, injected. 10 microliter, isn't it? 1 microliter. Okay, 1 microliter. Then, of course, in the process, the water will be changed into gas, as the name suggests.
Gas.
Then, as it will be moving through the oven, of which the oven is the one which will provide the condition for that kind of transition, eventually it will be detected. Detection will occur at that point because it's a FID detector. Then you will be in a position to see the chromatograms, which of course will be monitored on the screen of the computer, which is connected to the machine. So eventually, for you to be in a position to quantify the concentration of a particular constituent of a product, you'll calculate the area under the peak. So that area under the peak will be calculated, and you'll now get the concentration of your constituent of that particular product. So units will vary. Because we are making use of liquid, eventually you make your calculations based on the starting material. So if the starting material is in solid form, then we are talking about milligram per kg, microgram per gram, etc. But if the starting material is in liquid form, then you can talk of milligram per liter and so on and so forth. But then the unit ppm will eventually cut across, because there is a way in which you relate ppm to the units in the solid form and ppm to the units of the material in liquid form. Now here we have this equipment. This equipment is known as AAS, Atomic Absorption Spectrophotometer, that of course is used in the analysis of cations. In other words, we're talking about metal ions. So this equipment utilizes a particular flame. Of course, the gases that are used include that will enable you generate acetylene flame, which is combined with the oxygen in the air. The oxygen is generated from the compressor down there. So for you to be in a position to detect and eventually quantify the concentration of a particular cation of a metal in a sample, you need what is known as a cathode lamp. In other words, you can say hollow cathode lamp. So this is an example of a hollow cathode lamp. So for example, if you want to analyze for copper, what you need to do is to place your
analyze for
copper. Okay? You place your copper hollow cathode lamp there. Okay? So once you place it there and you now set your equipment appropriately, of course you'll need the standards, okay, of various concentrations. Let's say 2 ppm, 4 ppm, 6 ppm, 8 ppm, at least 4 standard concentrations. That is sufficient to generate a very nice standard curve, which will be used to quantify the concentration of copper in the sample. Okay, that will be done against the standard curve that will be generated using the standard concentrations of different.
We are talking of the copper ore.
Whichever the sample, even
okay.
Copper ore or any product that you wish
maybe.
to. Yes. Now, what matters is how you now prepare your sample. The target, of course, has to be in liquid form.
Okay.
So you can begin from liquid to liquid, or solid to liquid. Okay? Yeah, it's just a matter of preparing your sample.
Okay.
Of course, you can